Humanity has always gazed up at the night sky. From ancient civilizations to modern times, the stars have inspired countless myths, legends, and scientific discoveries. The night sky has been a canvas for our dreams and aspirations. We feel a deep yearning to explore the cosmos. This desire to venture beyond our planet has driven us to achieve incredible feats. From landing on the moon, to sending probes to the far reaches of our solar system, we dream of reaching out to touch the stars. The idea of traveling to distant planets and galaxies has captured our imagination for generations. It's a dream that pushes the boundaries of what we believe is possible. What if there were a way to make space travel as simple as riding an elevator? This isn't science fiction. The concept of a space elevator has been explored by scientists and engineers for decades, and it holds the potential to transform how we access space. This is the promise of the space elevator. Imagine a structure that stretches from the surface of the Earth all the way to space, allowing for a continuous and smooth journey to orbit. It represents a revolutionary concept that could redefine our future in space. By providing a stable and reusable pathway to space, the space elevator could open up new possibilities for exploration, research, and even tourism. Since the dawn of the space age, we have relied on powerful rockets. These rockets propel us beyond Earth's gravity. But rockets are expensive. The cost of launching payloads into space is a significant barrier to expanding our presence beyond Earth. They are also inherently risky. The complexity and power of rockets mean that even small errors can lead to catastrophic failures, endangering both missions and lives. The space elevator offers a compelling alternative. By eliminating the need for massive rockets, it could drastically reduce the cost and risk associated with space travel. It would provide a safe, reliable, and cost-effective way to access space. The space elevator could operate continuously, transporting people and cargo to orbit with minimal environmental impact. Imagine stepping into a space elevator. The experience would be unlike any other, offering a smooth and serene ascent to the stars. Picture yourself ascending effortlessly towards the stars. The journey would be a breathtaking experience, with stunning views of Earth and the cosmos unfolding before your eyes. This is the future we could build. A future where space is accessible to all, where humanity can explore, learn, and thrive beyond our home planet. The space elevator is not just a dream, it's a vision of what we can achieve with innovation, determination, and a shared sense of wonder. Picture a cable tethered to Earth. This cable stretches thousands of miles into space. It's anchored to a counterweight in geostationary orbit. This is the basic blueprint of the space elevator. Climbers or vehicles would travel along this cable. They would transport people and cargo between Earth and space. Unlike rockets, a space elevator wouldn't need massive amounts of fuel. It would utilize electric power. This makes it a far more sustainable and environmentally friendly option. Think of it as a celestial highway. This highway would open up a world of possibilities for space exploration, research, and even tourism. The concept of a space elevator isn't new. It has been a part of human imagination for over a century, capturing the minds of scientists and dreamers alike. It was first envisioned by Russian scientist Konstantin Tsiolkovsky in 1895. Tsiolkovsky, often considered the father of astronautics, laid the groundwork for many space exploration ideas that we take seriously today. Arthur C. Clarke popularized the idea in his 1979 novel, The Fountains of Paradise. Clarke's vivid storytelling brought the concept into the mainstream, inspiring a new generation of scientists and engineers to think beyond the confines of Earth. What was once a figment of imagination is now a serious engineering challenge. The idea of a space elevator has evolved from science fiction to a potential scientific endeavor, with detailed blueprints and theoretical models being developed. There are teams of scientists and engineers around the world actively working to make this dream a reality. The goal is ambitious, requiring unprecedented levels of international collaboration and innovation. Some experts believe a space elevator could be operational as early as 2035. This optimistic timeline reflects the rapid advancements in materials science and engineering. This timeline is dependent on overcoming significant technological hurdles. These include developing materials strong enough to withstand the immense stresses involved, and creating systems to manage the elevator's stability and safety. However, the potential benefits are so transformative that the endeavor is well worth the effort. A functioning space elevator could revolutionize space travel, making it more accessible and cost-effective, and opening up new possibilities for exploration and development beyond our planet. Imagine a future where traveling to space is as routine as taking a flight. The space elevator could make this vision a reality, bridging the gap between Earth and the cosmos and ushering in a new era of human achievement. As we continue to push the boundaries of what is possible, the space elevator stands as a testament to human ingenuity and our unyielding desire to explore the unknown. The journey from science fiction to scientific endeavor is a remarkable one, and it is only just beginning. Building a space elevator presents unprecedented engineering challenges. The most daunting of these is finding a material strong enough to withstand the immense tension and stress. The cable, after all, would be supporting its own weight over a distance greater than the diameter of Earth. The key lies in advanced materials. Carbon nanotubes, with their exceptional tensile strength, have emerged as the leading candidate. Graphene, another material with incredible properties, also holds promise. These materials are still under development. Their production on the scale required for a space elevator remains a significant obstacle. Section 5. Ascending to orbit. A paradigm shift in space travel. The completion of a space elevator would usher in a new era of space travel. It would dramatically reduce the cost of transporting payloads to orbit. This would open up space to a wide range of activities. Imagine launching satellites with ease. Picture constructing large-scale space stations or even lunar bases with readily available materials. Space tourism, once a luxury for the ultra-wealthy, could become a reality for many. Scientific research in the microgravity environment of space would flourish. The possibilities, quite literally, would be astronomical. Section 6. A universe of opportunities, economic and societal impact. The space elevator's impact would extend far beyond the realm of space exploration. It has the potential to revolutionize our global economy. New industries would emerge, focused on space elevator construction, operation, and maintenance. Jobs would be created in manufacturing, engineering, and space tourism. The environmental benefits could be significant as well. By reducing our reliance on chemical rockets, we could minimize the pollution associated with space travel. The space elevator could pave the way for a cleaner, more sustainable future for humanity both on and off Earth. Section 7. Space for All, the democratization of the cosmos. Perhaps the most profound impact of the space elevator would be its democratizing effect on space travel. This revolutionary technology could transform the way we perceive and interact with the cosmos. No longer would access to space be limited to governments and corporations with deep pockets. The barriers that once confined space exploration to an elite few would crumble, opening the final frontier to a broader spectrum of humanity. Researchers, entrepreneurs, and even artists could venture beyond Earth's atmosphere to pursue their dreams. Scientists could conduct experiments in microgravity, leading to breakthroughs in medicine and technology. Artists could find new inspiration in the vastness of space, creating works that capture the imagination of millions. Imagine a future where schools could send students on field trips to space stations. These young minds would be inspired by the first-hand experience of space, sparking a new generation of explorers, scientists, and innovators, where families could vacation in orbital hotels, gazing down at our blue planet. These experiences would not only be awe-inspiring but also foster a deeper connection to our home planet and a greater appreciation for its fragility. This is the promise of the space elevator, to make space accessible to all humankind, fostering a new era of exploration, discovery, and wonder. It represents a future where the cosmos is no longer a distant dream, but a tangible reality for everyone, regardless of their background or resources. The democratization of space could lead to unprecedented collaboration and innovation, uniting people from all walks of life in the shared pursuit of knowledge and adventure. Section 8. Overcoming the challenges on the path to the stars. Despite the extraordinary potential of the space elevator, numerous challenges must be addressed before it can become a reality. The development of super-strong, lightweight materials is paramount. The design must withstand the harsh conditions of space, including micrometeoroids, space debris, and extreme temperature fluctuations. Then there are the financial hurdles. The construction of a space elevator would require a massive investment. International cooperation and collaboration would be essential to pool resources and expertise. But these challenges, while significant, are not insurmountable. Section 9. A Future Among the Stars, Embracing the Space Elevator Dream. The space elevator represents a bold vision for the future of space exploration. It's a testament to human ingenuity, creativity, and our unyielding desire to push the boundaries of what's possible. While challenges remain, the potential rewards are too great to ignore. By embracing this dream, by investing in the research and development needed to overcome the technical hurdles, we can pave the way for a future where humanity becomes a truly spacefaring civilization. The space elevator is not just about reaching for the stars, it's about reaching for a future filled with limitless possibilities. Breaking innovation. The answer may surprise you. Recent breakthroughs in material science, particularly in the development of ultra-strong technology, as well as a deeper understanding of our place in the universe. Imagine a cable tethered to Earth, stretching all the way into space. This isn't just a science fiction dream, it's a concept that scientists and engineers are actively exploring. The idea is to create a direct link between our planet and the cosmos, a bridge that could transform how we access space. This is the essence of a space elevator. The cable, made from incredibly strong and lightweight materials like carbon nanotubes or graphene, would be capable of withstanding the immense forces involved. It would be a marvel of engineering, a testament to human ingenuity, and our desire to reach for the stars. This cable would be anchored to a platform in the ocean, a stable base that can support the structure's weight and withstand environmental conditions. The ocean platform would serve as the launch point for our journeys into space, a gateway to the final frontier. With its other end attached to a counterweight in geostationary orbit, approximately 22,236 miles above the Earth's surface, the cable would remain taut and stable. This counterweight could be a captured asteroid or a purpose-built structure, ensuring the system's balance and functionality. This cosmic elevator would allow specially designed climbers to ascend and descend the cable. These climbers, powered by solar energy or other advanced propulsion systems, would move smoothly along the cable, carrying passengers and cargo with ease. Transporting people and cargo to and from space would become routine. Imagine boarding a climber, watching the Earth shrink below you as you ascend into the heavens. The journey would be safe, efficient, and far less costly than current rocket launches. This revolutionary concept eliminates the need for expensive and fuel-intensive rockets. Traditional rockets require vast amounts of fuel and resources, making space travel costly and environmentally taxing. The space elevator offers a greener, more sustainable alternative, opening up a world of possibilities for space exploration and beyond. With a space elevator, missions to the Moon, Mars, and even further into the solar system become more feasible. The reduced cost and increased frequency of launches could accelerate our exploration of the cosmos. The implications of such a system are profound. It could democratize access to space, allowing not just governments and large corporations but also private individuals and smaller organizations to venture beyond our planet. It could revolutionize space travel, making it more accessible and affordable for everyone. Imagine students conducting experiments in space, or entrepreneurs launching new businesses in orbit. The possibilities are endless. Imagine a future where space tourism is commonplace. Families could take vacations to space hotels, experiencing the wonder of zero gravity and the breathtaking views of Earth from above. Space could become a new frontier for adventure and exploration. And scientific research in space is no longer bound by the limitations of rocket launches. Scientists could conduct long-term experiments in microgravity, leading to breakthroughs in medicine, materials science, and our understanding of the universe. The space elevator could truly be a cosmic connection, linking humanity to the stars. The biggest challenge in constructing a space elevator lies in finding a material strong enough to withstand the immense stresses involved. The concept of a space elevator has fascinated scientists and engineers for decades, but the practicalities of building such a structure have always seemed insurmountable. The primary issue is the tensile strength required for the cable that would stretch from the Earth's surface into space. This cable must be incredibly strong and lightweight to support its own weight and the weight of the climbers. Traditional materials like steel or even advanced composites fall short when it comes to the necessary strength-to-weight ratio. The cable would need to be thousands of kilometers long, and any material that is too heavy would collapse under its own weight before even reaching a fraction of the required length. Enter carbon nanotubes, a revolutionary material with extraordinary properties. These tiny structures, composed entirely of carbon atoms arranged in a cylindrical shape, have been the subject of intense research and development. Their unique molecular structure gives them unparalleled strength and flexibility, making them a game changer in the field of materials science. These tiny cylinders of carbon atoms possess incredible tensile strength, surpassing any other known material. In fact, carbon nanotubes are estimated to be over 100 times stronger than steel, while being only a fraction of the weight. This makes them an ideal candidate for the space elevator cable, as they can withstand the immense forces without breaking or stretching excessively. They are also surprisingly lightweight, making them the ideal candidate for this ambitious project. The lightweight nature of carbon nanotubes means that the cable can be extended to the necessary length without the risk of it collapsing under its own weight. This is a crucial factor in the feasibility of constructing a space elevator. The discovery of carbon nanotubes has reignited the dream of space elevators. With their exceptional properties, scientists and engineers are now more optimistic than ever about the possibility of making this science fiction concept a reality. Research is ongoing, and prototypes are being developed to test the practical applications of carbon nanotubes in this context. Their exceptional strength-to-weight ratio makes them the key to unlocking this groundbreaking technology. As research progresses, the dream of a space elevator moves closer to becoming a reality, potentially revolutionizing space travel and opening up new possibilities for exploration and development beyond our planet. Building a space elevator is a monumental task, fraught with engineering challenges. The construction process would involve manufacturing the carbon nanotube cable, deploying it from space, and assembling the anchor, climber, and counterweight. The cable deployment would be particularly challenging, requiring careful coordination and advanced robotics. Once assembled, the space elevator would need to withstand the harsh conditions of space, including micrometeoroids, space debris, and radiation. Despite these hurdles, the potential benefits of space elevators have spurred researchers and engineers to develop innovative solutions. The quest to overcome these challenges is driving advancements in robotics, material science, and space engineering. Section 5. A gateway to the cosmos. Benefits of space elevators. The successful construction of a space elevator would usher in a new era of space exploration. Lowering the cost of space travel is just the beginning. Space elevators could transport large quantities of materials and equipment to orbit, facilitating the construction of space stations, telescopes, and even solar power stations. This would pave the way for deeper space exploration, allowing us to send probes and eventually humans to Mars and beyond. The possibilities are limitless, from mining asteroids for resources to establishing permanent human settlements on other planets. Section 6. Pioneering the future. Organizations like Liftport Group. Organizations like Liftport Group are at the forefront of space elevator development. Driven by a vision of making space accessible to everyone, they are actively researching and developing the technologies needed to build a space elevator. Their work focuses on advancing carbon nanotube production, designing robust climber systems, and addressing the logistical challenges of space elevator construction. Through their tireless efforts, the dream of space elevators is slowly but surely becoming a reality. Section 7. Overcoming hurdles. Challenges on the path to space. Despite the excitement surrounding space elevators, several challenges remain. The sheer scale and cost of the project are daunting. International cooperation and massive investment will be crucial for its success. Safety concerns are also paramount. Ensuring the integrity of the cable and protecting against potential hazards like space debris are critical considerations. Addressing these challenges will require a concerted effort from scientists, engineers, and policymakers worldwide. Section 8. 2035. A realistic timeline or a distant dream. The goal of building a space elevator by 2035 is ambitious, but not impossible. Rapid advancements in material science, particularly in the field of carbon nanotubes, are making this dream more attainable. However, significant technological and logistical hurdles must still be overcome. The next decade will be crucial in determining whether this ambitious timeline can be met. Continued investment in research and development will be essential. Section 9. A new era of space exploration. The promise of space elevators. Space elevators hold the key to unlocking the full potential of space exploration. By providing a safe, reliable, and cost-effective means of accessing space, they could revolutionize our understanding of the universe and our place within it. The journey towards building a space elevator is fraught with challenges, but the rewards are immeasurable. If successful, this groundbreaking technology will usher in a new era of space exploration, opening up a universe of possibilities for generations to come. Free from Earth's gravity, the sight of a rocket launch with its powerful engines and billowing smoke has become synonymous with a new era in space travel. The dream of space elevators reminds us of the boundless possibilities that lie ahead. The journey to the stars is no longer. Imagine a cable tethered to Earth stretching all the way into space. This might sound like something out of a science fiction novel, but it's a concept that scientists and engineers have been seriously considering for decades. The idea is to create a direct and continuous link between our planet and outer space. This is the basic concept of a space elevator. It's a revolutionary idea that could transform how we access space, making it more affordable and sustainable. The space elevator would consist of a super-strong cable, or tether, made from advanced materials like carbon nanotubes or graphene, which are incredibly strong and lightweight. The cable would be anchored to a platform on Earth's equator and extend upwards to a counterweight in geostationary orbit, approximately 22,236 miles above the Earth. This counterweight could be a satellite or a space station, providing the necessary tension to keep the cable taut. Unlike rockets that require tremendous amounts of fuel to overcome gravity, a space elevator would utilize centrifugal force. This force, generated by the rotation of the Earth, would keep the cable stretched tight, allowing for a smooth and energy-efficient ascent. As the Earth rotates, the cable would be held taut by the counterweight, allowing a climber or elevator car to ascend the cable using electric power. This climber would be equipped with powerful electric motors and could travel up and down the cable, carrying passengers and cargo to and from space. This climber could transport people, cargo, and even spacecraft into space, eliminating the need for traditional rocket launches. Imagine the possibilities: regular trips to space stations, the moon, or even Mars, all without the need for massive amounts of rocket fuel. The space elevator could open up a new era of space exploration and development, making space more accessible to everyone. The most significant challenge in building a space elevator lies in finding a material strong enough to withstand the immense tension and stress involved. Here's where carbon nanotubes enter the picture. Carbon nanotubes are cylindrical structures of carbon atoms arranged in a hexagonal lattice. They possess extraordinary strength and stiffness, about 100 times stronger than steel at 1/6 the weight. This incredible strength-to-weight ratio makes carbon nanotubes the ideal material for constructing the space elevator cable. Beyond their potential to revolutionize space travel, space elevators offer significant environmental benefits. Traditional rocket launches release harmful pollutants into the atmosphere, contributing to air pollution and climate change. In contrast, space elevators would be powered by electricity, which can be generated from renewable sources. This means significantly reduced emissions and a smaller carbon footprint for space travel. By opting for space elevators, we can explore the cosmos while minimizing our impact on our home planet. Section 5. Opening the doors to space, tourism, and beyond. The realization of space elevators would usher in a new era of possibilities for humanity. Space tourism, currently limited to a privileged few, could become accessible to the masses. Imagine enjoying breathtaking views of Earth from a space hotel or embarking on a lunar vacation. Beyond tourism, space elevators could facilitate the establishment of research facilities, mining operations on asteroids, and even the construction of solar power stations in space. Section 6. Addressing the challenges, safety first. The concept of a space elevator, while promising, is not without its challenges. Concerns about safety, particularly the risk of collisions with space debris and the structural integrity of the cable, are paramount. Researchers are actively exploring mitigation strategies such as self-healing materials, redundant cable systems, and advanced avoidance maneuvers to ensure the safety and reliability of space elevators. Rigorous testing and simulations are crucial to address these concerns and build confidence in this revolutionary technology. Section 7. Building towards the future. A timeline. While a fully functional space elevator by 2050 might seem ambitious, the rapid pace of technological advancement, particularly in nanotechnology and material science, makes it a tangible goal. The coming decades will likely see the construction of prototypes, incremental increases in cable strength, and the development of advanced safety protocols. With sustained investment and global collaboration, the dream of riding an elevator to space could become a reality within our lifetime. Section 8. A giant leap for humankind. The development of space elevators represents a pivotal moment in human history. This groundbreaking technology has the potential to revolutionize the way we access space, making it more affordable and sustainable. Imagine a world where traveling to space is as routine as taking a flight across the globe. This is the promise that space elevators hold. It signifies not just a technological leap, but a philosophical one, fundamentally altering our relationship with space and our place within the cosmos. The concept of a space elevator challenges us to rethink our limitations and envision a future where humanity is not confined to Earth. It opens up new possibilities for exploration, colonization, and even the potential for interstellar travel. As we stand on the cusp of this new era of space exploration, the possibilities seem limitless. The construction of space elevators could lead to the development of new industries, from space tourism to asteroid mining. These advancements could create economic opportunities and drive technological innovation in ways we can only begin to imagine. Space elevators hold the key to unlocking our future among the stars, fostering scientific discovery, expanding our understanding of the universe, and ensuring the long-term survival of our species. By providing a more efficient and cost-effective means of transporting materials and people to space, they could accelerate the pace of scientific research and technological development. This, in turn, could lead to breakthroughs in fields such as medicine, energy, and environmental science. Just as the Apollo missions inspired generations past, the pursuit of space elevators ignites our imaginations today, reminding us that humanity's capacity for innovation and exploration knows no bounds. The dream of building a space elevator is a testament to our enduring spirit of curiosity and our relentless drive to push the boundaries of what is possible. It is a vision that unites us in a common goal, inspiring future generations to reach for the stars and beyond. Throughout history, humanity has gazed at the stars with wonder. From ancient civilizations mapping the constellations to modern astronomers peering through powerful telescopes, our fascination with the cosmos has been a constant thread through time. We have longed to explore the cosmos and unlock its secrets. The desire to understand our place in the universe has driven us to develop ever more sophisticated tools and technologies. For centuries, rockets have been our only means of escaping Earth's gravity. These powerful machines have carried astronauts to the moon, sent probes to distant planets, and launched satellites that connect our world. But what if there was another way, a more elegant and efficient way to reach for the stars? A method that could revolutionize space travel and make it more accessible to all. Imagine a ribbon stretching from Earth to the heavens, a celestial elevator carrying people and cargo into space. This ribbon, made of incredibly strong and lightweight materials, would be anchored to the Earth's surface and extend thousands of kilometers into space. This is the dream of the space elevator, a vision that could transform how we access space, making it as routine as taking an elevator to the top of a skyscraper. The concept of a space elevator may seem like science fiction, but it is rooted in sound scientific principles. Engineers and scientists are already working on the materials and technologies needed to make this dream a reality. The potential impact of such a technological marvel on humanity's future is profound. It could drastically reduce the cost of sending people and cargo into space, making space travel more affordable and opening up new opportunities for exploration and development. With a space elevator, the barriers to space travel will crumble, opening up a new era of exploration, discovery, and perhaps even the expansion of human civilization beyond Earth. Imagine a future where space tourism is commonplace, where new industries thrive in orbit, and where humanity takes its first steps toward becoming a multiplanetary species. The space elevator could inspire a new generation of scientists, engineers, and dreamers. It could become a symbol of human ingenuity and our relentless pursuit of knowledge and progress. Building a space elevator would require unprecedented international collaboration. It would be a project that unites people from all corners of the globe, working together to achieve a common goal. As we stand on the brink of this new frontier, the dream of the space elevator reminds us that the sky is not the limit. With vision, determination, and cooperation, we can reach for the stars and beyond. Imagine a cable tethered to a platform in the ocean. This platform would be a marvel of engineering, designed to withstand the immense forces exerted by the cable and the elements of the ocean. It would serve as the anchor point for the space elevator, a concept that has fascinated scientists and engineers for decades. This cable extends thousands of miles upward, far beyond Earth's atmosphere, to a counterweight in geosynchronous orbit. The material for this cable would need to be incredibly strong and lightweight, possibly made from advanced carbon nanotubes or other futuristic materials. The journey of the cable from the ocean platform to the counterweight would be a sight to behold, stretching seamlessly into the vast expanse of space. This counterweight, positioned at a specific point above Earth, would rotate in sync with our planet, keeping the cable taut. The counterweight's precise location and mass are crucial for maintaining the balance and stability of the entire structure. It would act as a stabilizing force, ensuring that the cable remains straight and secure, even as the Earth rotates beneath it. Climbers, powered by electricity or lasers, would then ascend this cable, carrying people and cargo to space. These climbers would be equipped with advanced propulsion systems, allowing them to travel smoothly and efficiently along the cable. The ascent would be a gradual and controlled process, offering a safer and more reliable alternative to the explosive power of traditional rockets. Unlike traditional rockets that require tremendous bursts of energy for a single ascent, space elevators offer a more sustainable and efficient means of space travel. Rockets rely on massive amounts of fuel and generate significant pollution, whereas space elevators would use renewable energy sources to power the climbers. This shift could revolutionize our approach to space exploration, making it more environmentally friendly and cost-effective. Once constructed, a space elevator would act like a railway to the stars, allowing for a continuous flow of traffic between Earth and space. This continuous operation would enable frequent and affordable trips to space, opening up new possibilities for scientific research, commercial ventures, and even space tourism. The space elevator could become a vital infrastructure for humanity's future in space, bridging the gap between our planet and the cosmos. The most significant challenge in building a space elevator lies in finding a material strong enough to withstand the immense tension and stress. The cable, stretching thousands of miles, must be incredibly light, yet capable of supporting its own weight and the weight of the climbers. Carbon nanotubes, with their exceptional strength-to-weight ratio, have emerged as the most promising candidate. However, even these wonder materials need to be manufactured to unprecedented lengths and purity. Other challenges include space debris mitigation, weather patterns on Earth, and the sheer scale of the project. Section 5. A new era of exploration, benefits of space elevators. The successful construction of a space elevator would be a game-changer for humanity. The most immediate benefit would be the dramatic reduction in the cost of space travel. With reusable climbers and a constant flow of traffic, the price of transporting payloads and people to space would plummet. This cost reduction would open up a plethora of new possibilities. Space tourism could become a reality for many, not just a select few. Space-based solar power could provide clean and abundant energy for Earth. Asteroid mining could unlock vast resources and fuel further exploration. Section 6. Navigating the risks, challenges, and concerns. While the potential benefits of space elevators are immense, it is crucial to acknowledge the risks. A catastrophic cable failure could have devastating consequences, potentially showering Earth with debris. The environmental impact of such a massive structure also requires careful consideration. Moreover, the sheer cost and complexity of the project raise concerns about feasibility and potential delays. International cooperation and coordination would be paramount to ensure the project's success and safety. Section 8. The power of collaboration, a global endeavor. The construction of a space elevator would be a testament to human ingenuity and collaboration. No single nation could undertake such a monumental task alone. It would require the combined expertise, resources, and willpower of the entire planet. International cooperation would be essential not only for the construction phase, but also for the operation and regulation of space elevators. A new era of space governance would need to be established to ensure equitable access and prevent potential conflicts. Section 9. A giant leap for humanity. The development of space elevators represents a pivotal moment in human history, akin to the invention of the airplane, or the launch of Sputnik. These milestones mark the beginning of new eras, transforming our understanding of travel and exploration. Similarly, the space elevator has the potential to reshape our relationship with space, making it an integral part of our lives, rather than a distant frontier. Imagine a world where space travel is as routine as a daily commute, where the boundaries of our planet no longer limit our aspirations. As we stand on the cusp of this new era of exploration, we must proceed with both ambition and caution. The journey to build a space elevator is fraught with technical challenges, from the materials needed to construct the tether to the energy required to power the ascent. The challenges are significant, but the rewards are even greater. Overcoming these obstacles will require unprecedented levels of innovation and collaboration across multiple disciplines, including engineering, physics, and material science. By embracing innovation, collaboration, and a shared vision, we can make the dream of a space elevator a reality, ushering in a new chapter in human history. This endeavor will not only expand our horizons but also inspire future generations to reach for the stars, fostering a culture of curiosity and exploration that transcends borders and unites humanity